All right, we're going to talk about matrix operations. So when we talk about matrix operations, what we're going to be talking about is addition, subtraction, scalar multiple, and then matrix multiplication. Okay, so addition and subtraction. So matrices are always in rows and columns. Okay, so when we look at a matrices, we're going to tell it by its rows, by the columns. So to have addition and subtraction, the matrices must be the same size. So it has to have the same number of rows and the same number of columns. So if I go A plus B, that's going to be the element Aij plus the element Bij. We're going to add those together. If I have subtraction, I'm going to subtract these. So here I have matrix A is -5, 0, 4, 1/2. B is 6, -3, 2, 3. This is a 2 by 2 matrix. This is a 2 by 2 matrix, so I am able to add and subtract them. So if I have A plus B, what I'm going to do is I'm going to go -5 plus 6, -5 plus 6, 0 plus -3, 4 plus 2, and 1/2 plus 3. And so I'm just going to add those. So I get 1, -3, 6, 7 halves. If you want to write this one as a decimal or a mixed fraction, that's fine. Okay, and then when I'm subtracting the elements from the same location. So -5 minus 6, 0 minus a -3, 4 minus 2, 1/2 minus 3, which gives me -11, positive 3, 2, -5 halves. Okay, so scalar product. A scalar product is taking a number and you're going to multiply a matrix. So what's going to happen is if I have, here I have matrix A is -3, 0, 4, 5. What I'm going to do is I'm going to multiply 3A times that. So I have 3A times this. So now I'm just going to take 3 and multiply it by every single element in there. So 3 times -3, 3 times 0, 3 times 4, 3 times 5. For my matrix of 3A is going to be -9, 0, 12, 15. Okay? So properties of matrix addition and scalar multiplication. A plus B is going to be B plus A. So in addition, I don't care about order. Okay? A plus the quantity B plus C equals the quantity A plus B plus C. Okay, so I can group them differently. If I have scalar K times scalar L, I'm going to multiply those together times A. I can actually do it in any order I want. K times the quantity LA. Okay, if I have a scalar times the quantity matrix A plus matrix B, I can multiply that scalar in first and then add them. So I can kind of distribute it. KA plus KB. If I have matrix A plus the 0 matrix, which is just zeros in all the elements, that's the same thing as having the 0 matrix plus matrix A, which is just A. Okay, this kind of makes sense, right? Add 0 to something, I get the number. A plus the negation of A is going to give me that 0 matrix. Okay, now, matrix multiplication, and this is where students tend to start having a little bit of struggle because it's a little bit different than traditional multiplication. Okay, so for an M by N matrix A, which has elements of Aij, and an N by P matrix B with elements Bij, the product AB equals the element Cij is an M by P matrix. Okay? So when we're looking at matrix multiplication, here we have AB. So A is a 2 by 3 matrix. B is a 3 by 2 matrix. So AB, which is 2 by 3, 3 by 2, what's going to happen is the size of that matrix, I look here, these middle pieces have to be the same. Okay, they have to be the same. They can't be a different value. So these are going to go away. leaving me with a 2 by 2 matrix. Okay? So I take my matrix here. 3, 1, 1, negative 1, 2, 0, 3. I'm going to multiply that by 1, 6, 3, negative 5, negative 2, 4. So what I'm going to do is I'm going to take the rows of my first matrix, times them by the columns of my second. So I have this, I'm going to multiply it by those columns. So what's going to happen here is now I have 3 times 1 plus 1 times 3 plus negative 1 times negative 2. So that's my very first element, is I'm going to multiply this whole row here by this column. Now I'm going to take this row and multiply it by the second column. So 3 times 6 plus 1 times negative 5 plus negative 1 times 4. Okay? And then my second row is going to be my second row times my first column. So 2 times 1 plus 0 times 3 plus 3 times negative 2. My next element is going to be my second row times my second column. 2 times 6 plus 0 times negative 5 plus 3 times 4. Okay? I'm going to run out of space here. So this is going to give me here, up on top, I have 3 plus 3 plus 2. There's my first element. And then I have 18 minus 5 minus 4 for my next element. I have 2 plus 0 minus 6. And then here I have 12 plus 0 plus 12. Now I'm just going to physically add those together. So I multiply these together, I get 8. This is 9, negative 4, 24. There is my product of these. So remember, it's always the rows of my first matrix times the columns of my second matrix. So it's the first element is row 1 times column 1. Element 1, 2 is row 1 times column 2, and so on and so forth. Okay, this is very, very important. Okay, matrix multiplication is not like traditional multiplication. Right? Traditional multiplication, 2 times 3 is equal to 3 times 2. Matrix multiplication is not. So if I took this, and I was lucky enough to have this, so let's kind of go B times A. Okay? So now I have a 3 by 2 matrix and a 2 by 3, which is going to give me a 3 by 3 matrix. So now I have here, I have 1, 6, 3, negative 5, negative 2, 4, times 3, 1, negative 1, 2, 0, 3. Okay, so I'm going to go here, my pieces here. So I have 1, my first element is 1 times 3 plus 6 times 2. My next element, 1 times 1 plus 6 times 0. And then I have 1 times negative 1 plus 6 times 3. Now I use my second row, and I'm going to use my second row, and I'm going to multiply everything, every single column. 3 times 3 plus negative 5 times 2. 3 times 1 plus negative 5 times 0. 3 times negative 1 plus negative 5 times 3. There's my second set of values. Now I go third row times every single column. Negative 2 times 3 plus 4 times 2. Negative 2 times 1 plus 4 times 0. Negative 2 times negative 1 plus 4 times 3. Now I have to physically multiply these out, get all the pieces. 3 plus 12, 1 plus 0, negative 1 plus 18, 9 minus 10, 3 plus 0, negative 3 minus 15, negative 6 plus 8, negative 2 plus 0, 2 plus 12. Now I'm going to add them. Here's my 3 by 3. 15, 1, 17, negative 1, 3, negative 18, 2, negative 2, 14. This is obviously not the same as this, right? Right? So sometimes you may not even be able to do the matrix. If I have matrices that don't line up, then I can't do the matrix multiplication. All right. So okay. So let's say I have these two matrices. Right. So I have a matrix here of 3, 2, 1, 8. And then I have a matrix here of 1, 6, 8. Okay? So this is a 2 by 2. This is a 3 by 1. I can't multiply those. There's no answer there. Okay? So, properties of matrix multiplication. A times the quantity B times C is the same as quantity AB times C. A times the quantity B plus C, I can kind of distribute that, AB plus AC. If I have quantity B plus C times matrix A, I can kind of distribute that, BA plus CA. Now the nice thing is, I can write equations in matrix multiplication form. So 4x plus 2y minus z equals 3, 9x plus z equals 5, 4x plus 5y minus 2z equals 1. I can write that in a matrix multiplication problem. So the coefficients go in one matrix, 4, 2, negative 1, 9, 0, 1, 4, 5, negative 2. That's one matrix. My next matrix is my variables, x, y, z, the vertical line. And then I have my last equals, my matrix, which is my equals, 3, 5, 1. So that's matrix multiplication and kind of working through those.